Okay, so this next part is going to be the properties and replacement set and the word problem. So just chunk it all into this one video. The first one we run into is which illustration illustrates the additive identity property. Now, you guys should have notes on this, and you'll be able to use your notes on the test. Lucky you. Not many math students can say that. So hopefully you can just referring back to your notes here. Identitive property. Now, the identitive property is what, if I have a number, say A, and I want to get back to A by adding, by something. What would that something be? Hopefully you think real hard and you're like, oh, 0. If I add something to 0, I always get back itself. That's it. So, we're looking for an equation here, and our choices are, write it in green, 8 times 9 plus 0 equals 8 times 9. 4 times 0 equals 0. 8 times 1 equals 8. And 1/4 times 4 equals 1. So what we're looking for is something that's adding to 0 to get back to itself. There is only one option that has adding in it and 0. So this is our solution. The 8 out in front, that doesn't really matter for this problem. So don't let that trip you up. The next one is use the distributive property. Use the distributive property to find 7 times 11 minus 8. Okay. The distributive property is you take whatever's on the outside and you distribute it to everything on the inside. So this is 7 times the quantity of 11 minus 8. Or 7 times 11 minus 7 times 8. Now 7 times 11 is going to be 77. 7 times 8 is going to be 56. And then you just subtract those two. So 77 minus 56, 7 minus 6 is 1, 7 minus 5 is 2, so my answer here is 21. Alright, the next one, find the solution of 3n minus 13 equals 38 if the replacement set is 12, 14, 15, 17, and 18. So, in layman's terms, what number of these in the set can I plug in for n that's going to give me 38? So you just need to do a little plug and chugging. So we'll start with 12. 3 times 12 minus 13. I should totally have a calculator for quick arithmetic, but I didn't think that far ahead. 3 times 12 is going to be 36 minus 13 is clearly not going to be 38. So 12 is not a doer. Try the next one. Whoa. Try the next one. 3 times 14 minus 13 equals, well, 3 times 14 would be 30 plus 14, which is 44. So 44 minus 13. 44 minus 13 is not going to give me 38. That's a no-go. It's too big. Too small. Totally didn't do that right. Too small. This was 4, 13, that would be 1, and fast at this arithmetic. 21, which is not 38, and 36 minus 13, which is 23, which is, again, is not 38. I feel like I'm doing that kind of wrong. This is 31. 31 and 23. Okay, next one, since 14 is not one. Try 15. 15. 3 times 15 minus 13 equals, 3 times 15 is 45. Minus 13. Sorry, blank out there for a second. 45 minus 13, that's going to be 32, which is not 38. You just keep going through it. We're getting close. We don't have very many options left. 3 times 17 minus 13 equals, well, 3 times 10 is going to be 30. Oh, I see what I did there. Let me go back and do this one. 3 times 14. 3 times 10 is 30. And 3 times 4 is 12. So this is 42. 42 instead of 44. But still, 42 minus 13. 12. 9, 3, 2. It's still not going to be 38. It's going to be 29. Didn't lose anything there. Alright, going back to 3 times 17. 3 times 10 is 30. 3 times 7 is 21. So this is going to be 51. 51 minus 13. Does it equal 38? That's the good question here. So, 51 minus 13. A borrow. 11 minus 30 is 8. 15, or 5 decreases down 1 because we borrowed. So 4 minus 1 is 3, which is our 38. So 17 is a solution. Now you can double check with 18. Just to make sure there's not multiple solutions in here. Most of you probably like, Ms. Ford, no, there is no multiple solutions. If you go any bigger, you're going to overshoot it. And I'm like, yes, you get it. So 3 times 10, because we're doing 3 times 80, or 18. 3 times 10 is 30. 3 times 8 is 24. So that's going to give me 54 there. Minus 13 is going to be 41. Which is not 38. So our only solution here is 17. And that's it. Alright, sweet. Oh.